Hi everyone, in this video we will cover past paper questions from 2016 to 2024 related to chapter 18, Introduction to Organic Chemistry. Okay, before doing the question, let's recall some of the important concepts related to this chapter. Okay, first of all, we have to understand what is homologous theory. Okay, if you just recall your periodic table, you will see that there are many groups in the periodic table, and the elements present in one group have the similar chemical properties. Why? Because they all have the same number of electrons in the last shell. So same is the concept of homologous series. Homologous series is actually a group of the compounds and they have similar chemical properties. Why they have similar chemical properties? The reason is because they have same functional group. Okay, so what is functional group? It can be atom or group of atoms that decide the chemical properties of an element. So we will see one by one different types of homologous series that we will discuss in this chapter. Okay, so what are the basic properties of homologous series? So homologous series, what is that? It's a group of the compounds that have same functional group. So when they have same functional group, they also have a same journal formula. And if they have a same journal formula, they have similar chemical properties. Remember, it's similar, not same, okay? What about the physical properties? Yes, their physical properties are not same, or you can say they are different, but there is a trend. They are gradual change you will see or observe in their physical properties depending on their number of the carbon atoms. So one of the example of the physical properties is boiling point. The boiling point of the organic compounds in a specific homologous series will increase once the number of the carbon atoms will increase. Okay, now let's see the different types of the homologous series depending on the functional groups. So first of all, you have to memorize alkanes. Alkanes have no functional group. In your book, it is given that they have a carbon single bond, but usually they don't have any functional group. Then the second one, we have alkenes. What is the functional group in alkenes? It is carbon-carbon double bond. At least they have one carbon-carbon double bond in their structure. Not all of them will be double bond, okay? Only one of them will be a carbon-carbon double bond. Then the third homologous series given in your book is alcohols. What is the functional group in alcohols? OH. OH is also called hydroxyl group. Then the fourth homologous series is carboxylic acids. The carboxylic acids have a functional group COOH. We also call it a carboxyl group, okay? The fifth homologous series is esters. Esters are not specifically mentioned in the start of the homologous series, but at the end of chapter 18, they are mentioned. And how esters are formed? When alcohols and carboxylic acids will react together, they will form esters. Along with that, they will also release the water molecule, okay? So, making esters, how esters are made? The condensation reaction between alcohols and carboxylic acid. Okay, why we call this reaction condensation? Because when two organic compounds or maybe other organic large compounds, when they react and they form a large product, along with that they release a small molecule. For example, here they release a water molecule along with the ester. So such reactions are called condensation reactions, okay? So these reactions require a catalyst, and the catalyst used during this reaction is H2SO4. Okay, it's sulfuric acid is required. Also, we can use phosphoric acid depending on the situation, but both of them are right. You can write phosphoric acid or sulfuric acid. Then, okay, esters have some specific properties. They have sweet, fruity smell. That's why usually they are used in the perfume industries and also in the baking industry, okay? Okay, now what else you have to memorize related to this chapter is the hydrocarbons. Okay, remember in the start, I told you the alkanes and alkenes. These two, the alkanes with no functional group and alkenes with the carbon-carbon double bond as their functional group, they both are called hydrocarbons. Okay, they are the only hydrocarbons. So what is hydrocarbon? Very simple, from the word you can know Hydro means hydrogen, carbon means carbon. So it means all those compounds that only contain hydrogen and carbon. No other atom or different type of element is present, then that will be hydrocarbons. So we have two homologous series that are considered as hydrocarbons, alkanes and alkenes. Okay. So in hydrocarbons, we have further two types depending on their nature of the double bond, okay, or the single bond. So if they have only single bond in them, we call them saturated, okay. Remember, saturated is not related to the solution. An exam, if the question is related about the organic compounds, then you have to write those compounds that only have single bond in them. Which single bond? Carbon-carbon single bond, not carbon-hydrogen. Okay, so carbon-carbon bond should be single, then they are called alkanes. If they have a carbon-carbon double bond, at least one, then such compounds are called unsaturated. So there are two types of hydrocarbons, saturated and unsaturated. Alkanes are saturated, alkenes are unsaturated. Okay, how you have to memorize that it is unsaturated? Unsaturated means that it can still be saturated. So how we can make it saturated? If you break this double bond and you can attach other atoms. For example, if there is a carbon-carbon double bond, if you break this one of the double bond and instead you attach H over here, also H over here, what does it mean? It means you can add something up still here, right? But in a saturated one, you cannot add something. That's why alkenes are the one they can do addition reaction. We can add something in that. What is that something? It's a compound or maybe some atoms. We can add it over there if you break this double bond, okay? But in alkanes, we don't have any double bonds. So usually there is no addition reaction take place. So that is the main difference between alkanes and alkenes. The alkanes and alkenes almost look similar. They are colorless. So how you can differentiate between an alkane and alkene? Through the addition reaction. We also call this addition reaction as bromination reaction. What does bromination mean? The addition of bromine. So alkenes will only react with the bromine or maybe chlorine. You can call also this reaction halogenation. If you are using any halogen, then you can see the change. So mostly because halogens are colorful, that's why we use for this reaction. And most of the common halogen that is used for this reaction is actually bromine. Because bromine color is obvious, you can easily see bromine. If you add the bromine is actually, what is the color? It is brown color. But if you are using an aqueous bromine, like bromine water, then it will be orange color, right? So when you add it into alkenes, the bromine color that was orange or maybe brown, it will change into colorless because the product will be a new one, that is chloroalkane, okay? But alkanes will not do any reaction. So you will see no change in color. The brown color will remain the same, okay? That is the difference between the alkanes and alkenes. We do the bromination reaction. Okay, now another concept you have to memorize related to this chapter is isomerism. What is isomerism? It's like compounds that have the same molecular formula, but their structure formula is different. So what is structure formula? What is molecular formula? What is journal formula? You must know that, okay? And this is already given in your book. So molecular formula, empirical formula, you already know from inorganic chemistry, but for structure formula is the formula in which you show the carbon. Okay, for example, we have ethane, and ethane has two carbons and it has 6 hydrogens, right? So if you write C2H6, then it is actually a molecular formula. But if you write CH3, it means you are showing that how many hydrogens are attached with each carbon. That is actually called structure formula. Okay, and the same structure formula is called display formula if you represent it in a form of a picture, or like if you show all the bonds. Okay, so you have to memorize actually the not even have to memorize, but you have to just understand the definition of the structure formula, display formula, because in exam they can ask you to draw the display formula, so you should know. If they ask you draw the structure formula, sometimes the student used to draw the display formula. That is wrong. So if they are asking you structure formula, you have to draw the structure formula. If you look over here, this is actually molecular formula. But if I write it like this, CH3, CH2, OH, then it is actually structure formula. Okay, I hope this is clear to you. Often we will see these type of isomers in alkenes also. also we will see in alkanes. Okay, we will go by one to that if we appear some question appear related to that. Okay, so now let's get started with the questions. Okay, first question, which formula is the same is in methanol, ethanol, and propanol? Okay, if you look at them, the name ends with OL, right? And it means they all belong to alcohol group. You have to memorize this one. This information is given in your book. You have to memorize the homologous series, right? And you also have to memorize that the name and then what does it mean. So OL means that they belong to alcohol group. So all of them belong to alcohol group. It means their general formula will be same. If you just recall the properties of homologous series, you will remember that general formula for the same homologous series is same. So B is the right answer. Question 3. An alkene is represented by the formula CH3, CH2, double bond CH2. You see, what is that? This is actually the structure formula, okay? Which name is given to this type of formula? So the formula that is showing you all the bonds, right? So usually in the structure formula, you don't show the single bonds, but you have to show the double bond if it is present. And in alkenes, we have the double bond, right? And only one double bond is present, so we are showing it over here. And this is actually the structure formula. I already told you, when you open all the hydrogens with that carbon, you show that, okay, this carbon has 3 hydrogen, the second has 1 hydrogen, and the third one has 2 hydrogen. So it means it's actually a structure formula. Question 4. The structure of an organic compound X is shown. What is the molecular formula of X? So it's simple. You just have to count the number of the carbons. You have to count the number of hydrogens. And then you can see what is the right answer. So the right answer is over here is C. You can count the carbon number are 7 and hydrogens are 12 over here. Question 5. Which molecules contain only single covalent bonds? So who has single covalent bonds? If you remember, it's actually alkane. The first homologous series, alkane, also have single covalent bonds. Also, alcohols also have single covalent bonds. So if you can find alcohol or alkanes here, so propane, alkane, A and E. So it means A is the right answer. Propane has all of the bonds are single. Why not propanoic acid? Because if you remember the structure, the functional group in propanoic acid is COOH. And how we write it? C has a double bond with O, and with another O, it has a single bond. And this O, because it needs 2 electrons, so it will make 2 bonds. So one with hydrogen, one with the carbon. Okay, so it has a double bond here. So that's why this one is also not right. Propene, again, propene, of course, it's a alkene, and alkenes always have a carbon-carbon double bond, at least one, right? And then we have propyl propanoate. This is actually ester, and esters are made up of alcohols and carboxylic acids, right? So of course they will also have a carbon double bond O. So this is the only one propane that don't have any double bond. It has all of them are single bonds. So A is the right answer. Question 6. Which two compounds are molecules which both contains a double bond, right? So double bond, who have a double bond? Alkenes. So we have to first find if we can see any alkene over here. Yes, we can find alkene here. Ethene. In C. Also in D we have ethene. Okay, the first one. Now let's see which one of them. Ethanoic acid. Yes, COOH. I already have told you. So it has a functional group COOH. Here, ethanol has an OH functional group, and then CH3 maybe. This is ethanol. So ethanol means it has 2 carbons, right? C2H5OH. So it means only ethene and ethanoic acid have the double bond in them. So C is the right answer. Question 7. Methane, ethane, and propane belong to a family of hydrocarbons called alkanes. What is the general formula of an alkane? So this is again related to your memorization. You have to memorize it, already given in your book. So alkanes, it's simple. How you have to memorize the general formula? If you know the sum of the compounds, okay. Before knowing the sum of the compounds, you must know that if there is 1 carbon in the organic chemistry, that compound will start with METH. Then if it has 2 carbons, it will start with ETH, right? So if it belongs to an alkane group, right, then the carbon will make a bond with 4 hydrogens. Why? Because carbon belongs to group 4. So it can only make 4. It has to make. Okay, it has to make 4 bonds to become stable. So you see over here, right? Now, ethane. Let's see. Now, if you have 2 carbons, right? Then look over here. If you see here clearly, this carbon also have 4 bonds, this carbon also have 4 bonds, and hydrogen has just 1 bond. Remember, hydrogen can only make 1 covalent bond and carbon can make 4 covalent bonds, right? So if I look over here, I have C2H6, right? So how I can make the general formula? According to this one, if I know the number of the carbon, then the hydrogen number is always 2n plus 2. If I look over here, it's CnH2n plus 2 again, because if it is 2, then it will be 2 into plus 2 is equal to 6, right? And if it is 1, 2 into 1 plus 2 is equal to 4. That is CH4, and this is C2H6, right? So this is the general formula for the alkanes. Alkanes have a general formula CnH2n plus 2. So if you know the number of the carbon, you will know the number of the hydrogens. And how you will know the number of the carbons? If you memorize this one, that what is the word used for 1 carbon, NETH. For 2 carbons, it's ETH. For 3 carbons, it's PROP. Okay, so you have to memorize it from your book. So D is the right answer over here. Let's see question 8. Alkanes are homologous series of hydrocarbons. The table shows the names and boiling points of the first 4 members of this series. Pentane is the next member of the series, which row gives the molecular formula and the boiling point of the pentane. So, how you will know what is pentane? What is the number of the carbon over here? Pentane, if you memorize from the book, you have to just memorize up till first 6 carbons, okay? So, pentane has 5 carbons. We can see already over here. But according to the general formula, if you memorize the general formula, it is CnH2n plus 2. So it means the number of hydrogen will be 5 into 2 plus 2. So it's 12. So the correct answer here is B or maybe D. Now we will look at the boiling point, okay? C5H12. So if you see over here the trend, the boiling point is increasing. I already told you when the number of the carbon number increase, the boiling point increase. So butane has a 0 boiling point. So how about the pentane? The boiling point will be greater than 0. So here 36 is the right answer, because here in 36 or minus 51. So minus 51 is less than 0, right? So 36 is the right answer. D is correct. Question 9. Which compound is not an alkane? CnH2n plus 2. So you just have to look to the number of the carbon and hydrogen. So here, how many carbons we have? 1, 2, 3, 4. So according to 4, we should have how many hydrogen here? 10, right? 3, 4, 5, 6, 7, 8, 9, 10. So A is an alkane. Let's see over here. Okay, 3 2s are 6, 7, 8, 9, 10. Again, we have 10 hydrogen and how many carbon? 4 carbon. That's also right. Here, let's see 3, 4, 5, 6, 7, 8. We have 8 hydrogens and how many carbon? 1, 2, 3, 4. This is CnH2n. That is wrong, right? It should be 2n plus 2. So it means C is not an alkane. Question 10. Which pair of formula represent 2 alkanes? So we just have to look to the general formula. According to the general formula, their formula should be CnH2n. So 8, right? 8 into 2 is 16 and plus 2 is 18. So, and this is CH2n plus 2 CH4. Of course, this is the first one, methane. We already know that is the right. So it means A is already the correct answer. You don't have to look into the detail of others. Question 11. What is the total number of covalent bonds in a molecule of butane? Okay, so you have to see the number of covalent bonds in butane, and this is C4H10. So it's easy. You just have to quickly make the display formula. This is the display formula. You draw 4 carbons first, right? Because it is C4 and then H10. Start drawing. All the carbons should have 4 bonds. Because it's butane, there is no double bond. It's all single bond, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Now let's call the covalent bonds. How many have? So you have to count these lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have total 13 bonds over here. So C is the right answer. Question 12. Which formula represents an alkene? Okay, so alkenes, what is alkene? Alkene, they have a carbon-carbon double bond. So the first example of alkene is not methane. ethene. Why? Because I already told you METH means one carbon, right? So the alkenes have a functional group carbon-carbon double bond. Between two carbons, there should be a double bond. In methane, we have just one carbon. So from where we can get the double bond now? So that's why in alkenes, the first compound is always ethene. It has two carbons, right? So we'll draw first the double bond between them, and then we can start attaching the hydrogens. Okay, now you will think there should be a hydrogen. No. Why? Because carbon can maximum make 4 bonds, and it already have made 1, 2, 3, 4, right? And look at this one carbon, 1, 2, 3, 4. So what is the formula? C2H2N. This is the journal formula. Okay, in journal formula, just remember from the word general. It has N in it. So your formula should also have a word N in its formula. Okay. So journal formula CnH2n is the right. So hydrogen will always be double. I can give you an example of the carbon that are 3, like propene. So in propene, at least one of them will be a carbon-carbon double bond, right? So now I'm going to attach the hydrogens here. Yes, they are complete. 1, 2, 3, 4 here. Only one, because 1, 2, 3, 4. Then here I will attach the 3. So look over here, how many carbons we have? 3. How many hydrogens we have? 6. So C2H6, right? So which formula represent an alkene over here? Sorry, this is not C2. C3H6 was the right answer. C3H6. So C2H4, yes, that's right. This is methane. No, this is wrong. And this is alcohol. The functional group is OH. So B is the right answer over here. Okay, look at this question. The structure of some hydrocarbons are shown. So this is actually called display formula, in which even we are showing the bonds, right? So this is display formula, not the structure one. If you remove these bonds from here and you just write CH3, CH2, CH2, CH3, then that is called actually structure formula. So now we have to see which statement about the hydrocarbons is correct. 1 and 2 have different journal formula. Wrong, because they both are alkanes. If you see, they are hydrocarbons, only carbon and hydrogen, and then all of them have a single bond. So what is this? 3 carbon propane. This is butane, right? So they have a different, 1 and 2 have a different journal formula. That is wrong. So let's see. This is a wrong statement. 1 and 4 are in different homologous series. Let's see 1 and 4. No, again, they are in same homologous series. Only carbon and hydrogen, and all of them are single bonds, right? 2 and 3 are structural isomers. Let's see over here. 2 and 3. Okay. Now you will say, okay, they have same molecular formula. Yes, right. But they have different structure. No, they have same structure. Remember, the structure formulas are not like this one. I will show you. Whenever you are drawing the structure formulas, you have to first count the number of the carbons. Like, how can you count in the alkanes? I'm talking about the alkanes because in alkanes, we don't have any functional group. So we cannot move the position of the functional group to make a structure isomer. So how structure isomers are made in alkane? I'm talking about the first homologous series, A and B. So usually what we do, we just move the whole CH3 from one side to another. Like, look over here. How many carbons I have? I can count from any side 1, 2, 3, right? In a straight chain. This is 1, 2, 3, 4, right? Okay, let's see over here. How many carbons I have? So in a straight chain, you will say, oh, we have just 2 carbons. No. The long chain we consider. The longest chain is actually your main chain. It's not always straight. You can go any direction, but you cannot repeat. For example, I can go like this. I can go like this. I can go like in a straight line. I can go like up. So you see, I can go from here, here, and here. You see, I go like this, this, and this. So I have not repeated anything. I have not come to any point again. So this is also 1, 2, 3, 4. So it is also a same one, butane, right? But if you look over here, this and this, or you can say 2 and 4, 3 and 4 can be structure isomers. How? If you look over here in the main chain, I have just 1, 2, 3. So I can go up like this. It will be again 1, 2, 3. See? Then this one is still missing. So you can say that they both are structure isomer 2 and 4 or 3 and 4. Okay. So this is called the structure isomerism, in which, so now the name of this compound will be, because the main have 3 carbons, right? So it will be propane. We call it propane because it has just 3 carbons in the main chain. Okay, but then we have a side chain like this one, or maybe you can consider this one. It's your choice. If you are considering like this one, then this is your side chain. But if you are considering this one as a main chain, then this is your side chain. So this group is methane, CH4, right? But this is CH4, it is CH3. So when one hydrogen is removed from an alkane, it becomes alkyl. So CH4 will become CH3 here, right? So this is called methyl, because one carbon means methyl. So this is methyl propane. So this is how you name the organic compounds, okay? So now let's see okay. So we are just left with the D option. So that's why D is the right option. But let's see what they have said. 3 and 4 have the same empirical formula. Empirical formula is the shortest formula of any compound. So if you see over here, how many carbons we have? 4 carbons, right? How many hydrogens here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So H10. Now the shortest formula of this one will be C2H5. Let's see over here if we have same number of carbons in hydrogen. Yes, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Same, right? So the empirical formulas, of course, both will have the C2H5. So that's why D is the right option here. Question 14. Methanol is a member of the homologous series of alcohols. What is the formula of the alcohol in the same homologous series which contain 3 carbon atoms? Okay. So for this one, you should have to memorize again the journal formula, right? So if you just remember alkanes have a journal formula CnH2n plus 2. Remember, if you know this formula, you will remember all the formulas for other homologous series because they are derived from actually alkanes. Okay, so in alkanes, actually, if you have CnH, for example, if I have 2 over here, then I have 6 hydrogens here, right? So now what happens in another homologous series, like in alcohols, once the hydrogen is actually removed, right? Then we are left with H5. So what else we have to attach over here? Because if you look over here at the carbon, there are 3 carbons, 2 carbons, and both of them have 3 hydrogens, right? So if I remove this hydrogen, this carbon needs to have another bond here, right? Because it still needs something here. So I can attach an OH group here, right? So if I attach the OH group here, it becomes an alcohol. Before it was ethane, now it becomes ethanol. Okay, so this OH has replaced one of the hydrogens. So what I can say, CnH2n plus 1 OH. So this is the formula for alcohols. So if you know this formula, then you can easily answer this question. So if we have 3 carbon atoms, so it will be C3. Then we will have how many hydrogens? 3 into 2 is 6 plus 1, 7. C3H7OH. So C is the right answer here. Question 15. Which formula represents ethanol? So from here, you can see ETH is always used for the 2 carbons. You already know 2 carbons. Now you already also know the journal formula. So it is CnH2n plus 1 OH, right? So if it is C2, it will be H5OH. So where is that? We have to look over here. So this formula is molecular formula. Here they have given you actually the structure formula. So I will open it. It will be CH3. The first carbon always have 3 hydrogens. And the second one will be CH2. So it is right. CH3, CH2OH. C is the right answer here. Okay, question 16. The table shows the boiling point of 4 members of the homologous series of alcohols: methanol, ethanol, propanol, butanol. What is the value of X? So the value of X should be between 78 and 117. So we have to find the difference that should be not very near to 78 and very near to 117. So 115 and 82 are not acceptable over here, right? Because it's just 4 degrees difference. This is just 2 degrees difference. Then what we are left with 55 and 98. Of course, 55 is not right because it should be more than 78. So we are just left with C option, that is 98. So 98 is the right answer. Question 17. Which compound has the most CH2 groups in one molecule? Butane, butanoic acid, butane 1-OL, and but1-ene. So we have to write their structure formulas first. So all of them are but. It means all of them have 4 carbons in them. Right? So the correct answer is C. So, but let's see how the answer C is right. So if you see C, so to look for the CH2, we have to write the structure formula. So butene is C4. According to the general formula, it is H10. Butanoic acid. Again, I told you if you remember this formula, you can find for other ones. So for butanoic acid, it is CN H2N plus 1, then COOH. This is actually your functional group, right? So it's butanoic acid. It has how many carbons? 4. So what the students usually do the mistakes in carboxylic acid group? They write C4 here. That is wrong. You have to write at least 1 carbon, not at least, must 1 carbon less in number. Why? Because 1 carbon is already here. So it means you should write here C3. Okay? Because this is C3 and this is the 4th carbon. So it is but. C3 and then this will be 7 C3H7COOH. Clear? Then we have butanol. Then it is butanol again C4H7OH. Sorry, C4H9OH. Then we have but1-ene. This is simple C4H8 because it is CnH2n. Now, let's see. I will write the structure formulas. C4H10, CH3. Then you will write CH2, CH2, and then you will write CH3. So we are done with that. Okay, it's simple. For alkenes, the starting and the ending will always be CH3, and the in center you will always have CH2. Okay, that is the trick for alkanes. Now let's see for butanoic acid. Again, CH3, the first one will always be CH3. The center ones will always be CH2, CH2, and the last one is actually your COOH. So how many CH2 we have here? 2. How many here? Also 2. Let's see for butanol. CH3 here. Okay, then CH2, CH2. Then again, I have CH2 and OH. You have to count. The number should be same. 2, 3, 4, 5, 6, 7, 8, 9. Right? 9. And this is OH. So how many CH3s we have? CH2 we have here? Of course, 3. So that's why C is the right answer. Let's see for butene. For butene, it's but1-ene. It means the first carbon has the double bond. Remember, okay? So the first carbon, if has a carbon-carbon double bond, then it means this one will be CH2 because 2 bonds are here and 2 will be here. Okay, 4. Then 1, 2, and then here again, how many I will have? Only 1. Why not 2? Because this carbon will have another bond here with CH2 and then CH3. I hope this is, you can draw the structure formula, then you will see that in one of them will be only having 1 hydrogen. So you see it has only just 1 CH2. So that is also wrong. So we have just a right option, that is butane 1-OL. So C is the correct answer here. Question 18. Organic compounds may have names ending in "ane", "ene", "ol", or "oic acid. How many of these ending indicates the compound contain double bonds in their molecules? So, alkanes don't have any double bond. "Ene", of course, they are alkenes. So, alkenes, of course, their functional group is carbon-carbon double bond. So, it means they have a double bond. Alcohol have an ending with OL. Alcohols also don't have any carbon-carbon, carbon, hydrogen, or oxygen double bond. So there is no double bond here. How about oic acid? It means they are carboxylic acids, right? So for example, ethanoic acid, or we can say like methanoic acid. So they have a functional group COOH, right? C double bond OH. So they have one functional group, that is carbon-oxygen double bond. So that's why there are 2. Enes and oic acids, they have a double bond in them. So that's why there are 2. Okay, so 2 is the right answer. That is B. Question 19. Which compounds have similar chemical properties? So for similar chemical properties, they should belong to same homologous series. Let's see for the first one, butanol. The name end with OL, the name end with oic acid. So it means they don't belong to same homologous series. Their name should end the same. Ethane, ethene, wrong again. Okay, this is ane. Methane, butane, yes, their names end with the same name, ane. So it means they both belong to alkanes, so they have similar chemical properties. So C is the right answer. Question 20. Which statement about unsaturated hydrocarbons are correct? Unsaturated, remember, so it means we can still make it saturated. It means the unsaturated has a carbon-carbon double bond because we can remove this double bond and we can make add a hydrogen here, right? So unsaturated will have a carbon-carbon double bond. Now let's see. They contain both single and double bonds. Yes, that's right. They have both single and double bonds, right? They turn because they have double single bonds like C and H have a double single bond, right? But between carbon and carbon, we have a double bond. They turn aqueous bromine from colorless to brown. Wrong. That is wrong because aqueous bromine is always colorful. It is actually orange or maybe brown, right? And then the product will be actually colorless. So the color change from brown to colorless, not from colorless to brown. So this statement is wrong. They can be manufactured by cracking. Yes, what is cracking? We will see it in more detail in the chapter 19 and 20. So cracking, you just have to remember that in the absence of oxygen, the large hydrocarbons are broken into smaller ones. So it's you are providing a very high pressure and high temperature to break the bonds between the hydrocarbons. Which hydrocarbons? Alkanes, okay? So alkanes, they are broken down and they will make the smaller alkanes and alkenes. So that's why unsaturated can be made by cracking. So 1 and 3, the both statements are right. That is a B. Question 21. Which reaction is used as a test for alkenes? So it is a bromine water test. We have to look over here. Any word? Yes, this is B. Alkenes decolorize the aqueous bromine. So the bromine color usually orange and then it becomes decolor. It becomes colorless when the product is formed. So B is the right option. Question 22. Which statement explain why ethanoic acid is saturated? So see, ethanoic acid actually have a carbon-oxygen double bond, but they are saying that it is saturated, right? It has a double bond, then why it is saturated? Remember, the definition of saturated in organic chemistry is that those compounds that have a carbon-carbon double bond, okay? Not carbon or any other element. So because this double bond is not between two carbon, so it is not a unsaturated one, okay? It is still a saturated because between carbons, all the bonds are single bonds. So A, of course, is not right. There is a carbon-oxygen double bond. No, that is not the reason. The carbon-carbon double bond in the carbon-carbon bond in the molecule is a single bond. Yes, that is the right answer, okay? All the carbon-hydrogen bonds are single bond. No, this is not about carbon, hydrogen, or carbon, any other element. It's all about carbon-carbon bond, okay? So C is the right answer here. Question 23. X, Y, and Z are 3 hydrocarbons. Okay, we can see here. What do compounds X, Y, Z have in common? So if before looking at this, we have to see, yes, all of them have carbon-carbon double bond, right? So they all are alkenes. Yes, that's true. They are all part of the same homologous series. Yes, that's also right because they have a same functional group, that is double bond. They all have the same boiling point. No, that's not right because boiling point increase with the increase in number of carbons and you see the carbon numbers are increasing. So only the statement 1 and 2 is right. That is option B. Question 24. The structure of 4 organic molecules are shown. Okay, we can see over here. Okay, how many different homologous series are represented by these molecules? First of all, this is chloromethane because this is 1 carbon, right? And it has a chlorine with it. If it has only hydrogen, we will say it's methane. But it has 1 chlorine attached to it, so the name will be chloromethane. Now let's see over there. So this is one of the homologous series. It belongs to alkanes, right? This is the another homologous series because it has a COOH functional group. Then the third one is OH as a functional group. Here we also have OH as a functional group. So they both belong to same one. One homologous series, second and third. So total we have 3 homologous series represented over here. That is C. Question 25. Which row identified compounds in the same homologous series? So their chemical properties will be similar, right? So C and D will be right. Functional group, of course, same. That's why their chemical properties are similar. So that is why D is the right answer. Question 26. Which statement about a homologous series is correct? Okay. All members have the same journal formula. Yes, that's right. They all have a same journal formula. So option A is correct. Question 27. Which statement describes the members of a homologous series? Compound with the same physical properties is wrong because the carbon will change the physical properties, right? The number of carbon. Compound containing the same functional group. Yes, that's right. Homologous series, the functional group will be same for the group of those compounds that are in a same homologous series. So B is the right answer. Which statement about homologous series is correct? Members of a homologous series have the same structure formula. No, that's not right because if the carbon numbers are increasing, their structure, their molecular formulas will change. Members of homologous series all have similar chemical properties. Yes, that's right because they have same functional group, so their chemical properties are similar. So B is the right answer. Question 29. Which statement about the members of homologous series is correct? Successive members differ by CH3. No, they actually differ by CH2. How? I can show you over here. Let's see methane, right? It is CH4. Then we have CH3. Then we have CH3. That's a simple one. But now let's see about the propane. This is ethane. This is methane, ethane, now propane. So between this one, we will have now CH3, CH2, CH3. Can you see here? One CH2 has been added. Okay. Next one will have the CH3, CH2, CH2, CH3. So what is the difference here? One more CH2. That's not only the case in alkanes. Even I can give you an example of alkenes. Let's see the alkenes example. The first one is CH2, CH2, right? So now the next one will be CH3, then you will have CH, and then you will have CH2. You see, what is the difference? There were four hydrogens here. Now, how many hydrogens we have here? More. 2 hydrogens are more because 3 and 4 is already the same here, right? Okay, now I will give you another example, the next one. CH3, CH2, CH, CH2. You see, what is the difference? CH2 is the difference. So they all differ by CH2. You can see in the structure formulas. Then successive members have a molecular mass that differs by 14. So let's see, because CH2 is the difference, right? The CH2 is the difference. So successive members means the next member from here to here, the difference will be 14, the mass difference. So because CH2 is increasing, so the mass of carbon is 12 and the mass of hydrogen is 2. So total 14. Yes, B is the right answer here. Question 30. Which statement about compounds in the same homologous series is correct? They had the same chemical properties because they have same number of carbon atoms. No, they don't have same. They have similar chemical properties, right? Okay. They have the same physical properties because they have the same number of carbon atoms. Again, wrong. They don't have same physical properties. They have different chemical properties. Again, wrong. They don't have different. They have different physical properties because they have different number of carbon atoms. Yes, D is the right option because their physical properties change according to the number of carbon atoms. So D is correct. Question 31. Why is ethanol a member of homologous series of alcohols but propane is not? Alcohols, what is the functional group in alcohols? OH, right? So ethanol have an OH in it, but propane don't have OH. So we have to find this option. Ethanol has 2 carbon atoms. No, that's not the reason. Ethanol can be made from ethene. No, that's not the reason. Ethanol is a liquid, but propane is a gas. No, ethanol contains the same functional group as other alcohols, but propane does not. Yes, that's the right option. D is correct. Question 32. Which statement about homologous series is not correct? All homologous series are hydrocarbons. No. There are only alkanes and alkenes that are hydrocarbons. But alcohols, carboxylic acids, esters, they are not hydrocarbons because instead of carbon and hydrogen only, they also have oxygen in them. So A is a wrong statement. Question 33. Which statement about homologous series is not correct? Alkenes have the same general formula CnH2n plus 2. Wrong. Alkenes. This is alkanes formula. So alkenes have CnH2n. So that's why A is a wrong statement again. Question 34. Which statement about homologous series are correct? All members have similar chemical properties. Yes. All members have the same molecular mass. Wrong, because the carbon number will change, so of course the molecular mass will change. Ethane and ethene are the members of the same homologous series. Wrong, because its name ends with ene and this ane, right? So the last name should be same. Ethane and propane are the members. Yes, they are the members of the same homologous series. So 1 and the fourth option, that is B, is right. Question 35. 4 statements about members of the same homologous series are listed. They had the same volatility. Again, this is a physical property. The volatility will depend on the mass, on the number of the carbon, and this will decide their boiling point. So lower the boiling point, more will be the volatility. So this is wrong, okay? Now let's see, they had the same molecular formula. Again, wrong. It depends how can all the compounds in the same homologous series can have a same molecular formula. Of course, when the carbon number will change, their molecular formula will also change. They have a same functional group. Yes, this is a right option. They have the same general formula. Yes, that's also true. So option D is correct. Question 36. 4 statements about organic compounds P, Q, R, and S are listed. P is a saturated hydrocarbon. Okay, so we can write one by one. Saturated hydrocarbon means it's an alkene, right? Alkenes are, alkane. Not alkenes, it's alkane. Alkanes are saturated because they have only carbon-carbon single bonds. The formula of Q is CH3CH3. So it means it's C2H6. That is also an alkane, right? A molecule of R contains only one oxygen atoms. And who have one oxygen atoms? That is actually alcohols, because in alcohols we have a OH group. Not a carboxylic acid, because in carboxylic acid we have 2 oxygen. Compound X is carboxylic acid. Okay, right. Now let's see the statement one by one. Which statement about this compound is correct? P and Q are the members of the different homologous series. P and Q, wrong, because they both are alkanes, right? P and S are the members of same homologous series. P and S, again wrong. Alkane and carboxylic, not same. Q and S are the members of the same homologous series. Q and S, again wrong. Q, R, and S. Okay, Q, R, and S are the members of different homologous series. Yes, right. One is alkane, the other one is alcohol, and the last one is carboxylic acid. So D is correct. Question 37. Which of the compounds shown are in the same homologous series? So if they are in the same homologous series, they will have a same functional group. OH, yes, it has also have a same functional group, OH. But if you look over here, it was CH2OH, but here it is COOH. It means this is not alcohol. It is actually carboxylic acid. So 1, 2, and 4th, they all are alcohol. 1, 2, and 4, that is B. Question 38. The formula of 5 compounds are listed. Which compounds are in the same homologous series? So first C4H10, can I find the same one? No, there is no other one. Here we have alcohol OH. Yes, this is also alcohol OH. This is not an alcohol because this is COOH, right? Then this is also an alcohol. So 2, 3, and 5 are from the same homologous series. That is option B. Question 39. Which compound does not belong to the same homologous series as the other 3 compounds? So let's see one by one. OH, it has a functional group. This one has a COH as a functional group. This one has OH. This one also have OH. So it means this is different, right? So option B is correct. Question 40. The structure of a compound is shown. Which functional groups are present in this compound? So look over here. We have a carbon-carbon double bond. So it means it has an alkene functional group, right? So A or C can be right. Now let's see for carboxylic acid group. COOH. Yes, we have a carboxylic acid group here. How about the alcohol group? So here the most of the student will get confused. They say, oh, OH is here, so it will be alcohol. No. OH should be directly attached with any CH group, but this is actually COOH. This whole is one functional group, right? So it has alkene, it has carboxylic acid, but no alcohol. So that is why option C is correct. Question 41. The structure of some organic molecules are shown here. Okay. Which structure represents an alkane with 4 carbon atoms? This is alkene because it has a carbon-carbon double bond, right? And they all are alkanes. So now we have to count the number of the carbons. Here we have 1, 2, 3, 4. Yes, this one has 4 carbons. So 2, 1, 2, 3. Here we have 3. So that's not right. 1, 2, 3, 4. So 2 and 4 have 4 carbon atoms. That is C. Question 42. The diagram represents ethene. Which compound have the chemical properties similar to that of ethene? So it means we should have another alkene over here that has a carbon-carbon double bond. And if you look over here, only option D is right because we can see a carbon-carbon double bond here. Question 43. Which structure represents a molecule of ethanol? It means alcohol group. It should have a functional group OH. So here we can't find any OH. Here no OH. Yes, here we can find the OH. So option C is right. Here if you look at OH, this OH is attached to the carbon. There's this attached with another oxygen. So if you find a group COOH, that is actually carboxylic acid, not alcohol. Okay. So C is the right option here. What is the structure of propanol? So it will have an OH over here, right? So how many OH we can have here in C and D, right? So C or D can be right. But the word is propanol. So prop means 3 carbons. So where we can find 3? Of course, in option C. So that's why option C is correct. So that's why it's important to memorize that what does prop means, what does but means, what does eth means, because this wording will be same for all the homologous Cs, the starting one, depending on the number of carbon, okay? And in IGCSE, it's very easy. You have to just memorize the first 6 carbon atoms. So first is meth, second is ETH, the third one is prop, fourth is but, and the fifth one is pent, and the sixth one is hex. Okay, you just have to memorize this one. More than this one, they will give you in the exam already. You don't have to memorize that. So let's see now question number 45. The structure of compound R is shown. Okay, so it's of course alcohol, right? What is R? So it's a propanol because alcohol ends name with OL, and then if you see there are 3 carbons. So it's a propanol. Option C is correct. Question 46. The table shows the bonds that are present and the bonds that are not present in compound X. What type of the compound is X? Carbon single bond. Of course, in all the organic compounds, usually we find carbon single bond. There's no carbon-carbon double bond. So it's not an alkene. D, not correct, right? So we are just left with A, B, and C. CH bond is present. Of course, it's present in all these 3. CO is present. See over here. So in alcohols, we also have CO bond, right? COH, right? So it means it can be alcohol or maybe carboxylic acid, not alkane, because in alkane, we don't have an O. I see double bond O is also present over here. Then OH is also present. It means it is actually a carboxylic acid because in carboxylic acid, we have COOH, right? So it means this is a right option over here. It's a carboxylic acid, A. Which structure show a carboxylic acid? Again, COOH. You have to find a functional group. Okay, so C is a right option here. How many of each type of bonds are present in ethanoic acid? CH3COOH. So here, CH bonds, how many? If you look over here, carbon is bonded with 3 hydrogens, right? So CH are 3 hydrogens. Then carbon is how many? Carbon, and this carbon will have 1 bond if you look at the structure. So 1 carbon bond. So it means A is the right answer over here. Then C double bond O, of course, 1 C double bond O will be present because this is COH group. So A is the right answer here. You can also draw the display formula to confirm that this answer is right. Question 49. What is the structure of propanoic acid? So these are the display formulas. Let's see one by one. All of them should have COH, right? Because it's a oic acid, right? Propanoic. So prop means 3 carbons. So COH is present. Yes, here also COH is present. So how many carbons we should have? 3. You have to consider the carbon in the functional group. So this is the right answer, not this one. Don't think that this is 1, 2, 3. So it's right. No, you have to consider this carbon also. That is a part of functional group, okay? So A is the correct answer here. Question 50, what is the structure of butanoic acid? So but means 4 carbon and then oic acid means COH is the functional group here. So C or D can be right. But now it has 4 carbons. So let me count 1, 2, 3. That's wrong. 1, 2, 3, 4. So D is the correct answer here. Question 51. What is the structure of butanoic acid? So again, butanoic acid will have 4 carbons. So you have to first find where you can find 4 carbon. 1, 2, 3. No. 1, 2, 3, 4. 1, 2, 3, 4, 5. That's wrong. 1, 2, 3, 4, 5. So it means B is the right option here. You don't have to go in detail because you already know but means 4 carbons. So CH3, CH2, CH2, COOH is the right answer. That is B. Question 52. Which diagram shows the structure of pentanoic acid? So pent means 5, right? So you have to look for the 5. So it's the only this one you can see over here. According to the functional group, we only have COH over here. No need to count the number of carbons even because even there is no COH over here, right? So only we have here. And even if you count the number, there will be 5 of carbon. 1, 2, 3, 4, 5. So D is the right option. Question 53. The structure of 4 organic compounds are shown. Which compounds are unsaturated? So for unsaturated, one will have a double bond in them. That is only V over here. If you look over here, that is the D option, that is unsaturated. Question 54. Which structure is correctly named? Ethanoic acid. So ETH means it should have 2 carbons. Here we have 3, so it is wrong. Ethene, it should have 2 carbon. Yes, that's right. But the name should end with, the name is ENE. So it should have a double bond. That is wrong now. Ethanol, 2 carbon. Yes, that's right. And OL means it should have a functional group OH. So it means C is the right answer. Why not D? Because it has a carbon-carbon double bond. So it should be propene. 3 carbons, but propene. Okay. So C is right. Question 55. Which diagram show the display formula for the name organic compound ethanoic acid? 2 carbon. Yes, that's right. But if you look at the functional group COOH, there should be 2 oxygen. But here total we have 3. That is wrong. Ethene, 2 carbon. Yes, right. And how about the ENE? Yes. But if you look carefully, this carbon is making how many bonds? 1, 2, 3, 4, 5. That is wrong. Carbon cannot make 5 bonds. It can only make 4 bonds. So ethene is like CH2, CH2, not CH3, CH3. So it's wrong. Then look over here. Ethanol. Yes, that is right. See, we can already see the option here. But let's see how. Because it's CH3, yes. Then we have CH2 and then we have OH as a functional group. And if you see clearly, carbon is making 4 bonds. This carbon also making 4 bonds. Hydrogen is just making 1 bond and oxygen can make maximum 2 bonds. So you can see all the bonds are also correct. So ethanol is the right option here. This is actually ethane because it has 2 carbon. So it should be ethane, not methane. So that's why C is the only right option here. Question 56. The diagram shows the structure of 2 organic molecules. Which statement about these molecule is not correct? So both are alcohols, right? They have OH as a functional group. They are both alcohols, yes, right? They both produce carbon dioxide and water when they burn in oxygen. Yes, true. Remember alkanes, alkenes, alcohols, whenever they will react with the excess supply of oxygen, the product will always be carbon dioxide and water. No matter whatever the homologous series is, alkane, alkenes, alcohols, all of these 3 will give you carbon dioxide and oxygen if the oxygen supply is more. But if the oxygen supply is less, then the product will be, instead of carbon dioxide, it will be carbon monoxide and water. Okay, so carbon dioxide and water when more oxygen, when less oxygen, carbon monoxide and water. More oxygen, carbon dioxide and water. So see, they contain different functional groups. Wrong. They have same functional group. So that's why this option is not right. Option C. Question 57. An ester is formed when carboxylic acid react with an alcohol. Which ester is formed when propanoic acid react and ethanol react? Okay, so this is the main topic you need to know and understand how esters are made. So first of all, you should know the carboxylic acid functional group and alcohol functional group. I will give you an example and I will show you how the structures are made. Okay, so I will start with the simplest example like ethanoic acid. And let's see for ethanol, right? So this is an ethanol and I have to write this formula. CH3, this is CH2 and OH, right? Let's see for ethanoic acid. Then ethanoic acid is CH3COOH. Remember, two carbons are already complete, right? Now when they both react, remember this reaction was condensation reaction. They both will react to form an ester plus a water molecule will be released. So because water molecule is made up of H and OH, right? So who will donate the OH? Who will donate H? Remember, carboxylic acid will always donate OH group and alcohol will just release its H group. So H will be released from here, OH will be released from here, and then this and this one will make the bond. So what will be the bond now here? Usually you can write like this, CH3, CH2, O, right? You write O, but then you cannot write CH3. This O and this CO will make a bond because here the bond has broken, right? Here the bond has broken. So they have to get attached with each other. So now what will happen? O, C double bond O, because this is C double bond O. OH is removed, C double bond O is still here. So this is how it is made, okay? This is the structure of an ester. But usually we write carboxylic acid first. Remember, carboxylic acids are written first and then alcohols are written. But sometime in the exam, they can give you a structure that will have alcohol first, okay? How you will know that one? You must know, okay, first I have to tell you how to name it. Whenever you are naming the compound ester, you have to name alcohol first. You see the alcohol is ethanol over here, right? So the name will be ethyl. Ethanol will change into word ethyl and propanoic acid name will come later. So it will become ethyl propanoate. So oic acid will change into ATE. So the name of this compound will be ethyl propanoate, right? But when you are drawing the structure of propanoate will be first. So I will write the structure again for you, for example. So this is propanoic acid. Instead of ethanoic, we are using propanoic. So I can write CH3, CH2, and COH, right? This is propanoic acid. So the OH was removed. So what I am left with? CH3, CH2, CO, right? And what is here? Ethanol. So ethanol was CH3, CH2O because H has been removed. So this O will join over here. So you will start from the back side, right? CH2, CH3. So the corners will be always CH3 and in between you will always find a COO bond. Okay, COO, the carbonyl bond, or you can say this is called the ester bond because this is not COH, right? So this is actually called ester bond. Clear? So this bond, whenever you will see, it is actually your ester. So now where I can find the structure because it is formed between ethanol and propanoic acid. So propanoic acid I should find first where I can see 3 carbon before this COO. So this is my functional group, right? So, right. So now I have to find propanoic acid. 3 carbon. 1 is already here, right? And the 2 are here, right? 2 are here. So propone is fine. How about ethanol? Ethanol means it should have 2 carbons, right, from the alcohol group. So it has only 1 carbon from the alcohol group. It has 2. So this is actually methyl propanoate. This is ethyl propanoate. So that is the right option here. So option D is correct. Question 58. An ester C4H82 is made by reacting 0.06 mole of ethanol and 0.05 mole of ethanoic acid. 0.0375 mole of ester was made. What is the percentage yield and the MR of the ester? Okay. So if you look here, 1 mole of alcohol, 1 mole of this one, carboxylic acid will give you 1 mole of an ester. But here we are using how many moles of ethanoic acid? 0.05. So it means, and this one we are using 0.06. So what does it mean? It means this one is the limiting reagent. So here I'm going to get 0.05, right? 0.05 I'm going to get, but they say we are going to get 0.0375 only. The answer should be 0.05. So it means it is not. So it is less than 0.05. So we have to calculate the percentage yield. So it will be 0.375 divided by 0.5 into 100. You will get 75% as the percentage yield you have got. So it means the yield is not 100%, it is 75. So it means B and D is right. You can do the calculation yourself. Now we have to find the mass. So it is C4H8O2, right? So you can do the calculations and you can calculate the mass yourself, and then you will find the right answer is 88. Okay, the MR is 88, so D is the correct answer. Question 59. Which substance react together to form ethyl propanoate? So you need to know. The first name always comes from the alcohol. So it means ethanol was used here, right? Propanoate means propanoic acid was used here. So ethanol and propanoic acid. Option D is correct. Question 60. The formula of an ester. Oh God, this is given over here. So we have to count. First, you have to find the functional group. That is ester functional group CO, right? I already found it. Now I have to find my alcohol and acid. So where you will find the CO, that is actually the part of, because you have to break it in between. So you will break CO on one side, oxygen on the other side. This CO will always be the part of the carboxylic acid, because in only carboxylic acid we have C double bond O, right? The OH was already removed during the formation of the ester. So this is your actually carboxylic acid, and this O up till from O to here, it is your alcohol. I hope this is clear to you. So now we have to count the number of the carbons. Simple. 1, 2, 3. So there are 3 carbons in the alcohol. So it means 3, the word 3 is prop. So it's actually propanol that was used here. Clear? Now let's see for here. How many carbons we have here? 1. Don't forget to count this carbon that is a part of carbonyl group. This is actually your butanoic 1, 2, 3, 4. Yes, butanoic acid, right? So you have to count this carbon of the functional group in the carboxylic acid part, okay? So 1, 2, 3, 4. 4 is but. So butanoic acid. That is why option B is correct. Question 61. Which pair of compounds can be used to prepare CH3, CH2COO, CH2CH3? Okay. Again, I will find first COO, right? Then I will break this bond. So this is a part of the carboxylic acid. How many carbons I have? 3. So it is made up of propanoic acid. Yes. Okay. How about this one? How many carbons I have? 2. So it's made up of actually ethanol. So option C is the right option here. Question 62. The structure formula of compound Q is given. Okay, again here. What is compound Q? So we have to first find the carbonyl group, right? Then I have to find the alcohol group. This is my alcohol group. How many carbons I have here? 3. Alcohol group always name first, right? Even it is written at the end, but the naming it should be first. So how many carbons I have here? 3. So it means it's made up of propanol. So the name will be propyl. Clear? Now, how many carbons I have here? 1, 2, 3, 4. So it is made up of butanoic acid. So the butanoic acid name will change into butanoate. So the answer is propyl butanoate. Can I find here? Yes, option C is correct. Question 63. Which structural formula represent methyl propanoate? So methyl means the alcohol that was used was methane, only 1 carbon. So first I have to find the CO group, ester group. CO is here. Yes, CO is here. Okay, then CO is here. And then COO is here, right? Okay, so it is because methyl. So methyl alcohols are usually written at the end. So this end, if I see over here, this is only 1 carbon. It's methyl. Yes, that's right. If I see over here, yes, this carbon is also 1. This is also methyl, right? This is wrong. This is not right. Now, propanoate. It means 3 carbons I have to find here. So how many carbons I have here? 1, 2, 3. How about here? I have 1, 2, 3, 4. So that's wrong. This is the right option. Option A is correct. Question 64, which formula represents ethyl butanoic? So it means in the butanoic acid, we have used butanoic acid here, 4 carbons. And in ethanol, it is actually 2 carbon. So first of all, again, I will find the CO group here, right? I already have to circle it. Then you know that this is the alcohol group. Alcohol groups are written in the structure at the end. So I have to find here how many carbons I have here. 2. Yes, this is ethyl. Here, so many. No, this is not ethyl. How about here? Yes, it is 2. So again, it is ethyl. That is right. So this is also not right. Now I have to look for butanoate, 4 carbons. So 1, I have to count it, right? 1, 2, 3, 4. So this is the right answer. Let's look over here. 1, 2, 3, 4, 5. That's wrong. 5 is pentanoate, but it is butanoate, right? So option A is correct. Question 65, methanoic acid and propane 1-OL react to form an ester. What is the structure formula of the ester? So you see it's methanoic acid. Remember the structure formula of methanoic acid is HCOOH. Clear? COH already because it has only 1 carbon. So COH, this C is already a part of the function group. So we cannot add any other CH right here, CH2 or something else. So only H will be attached here. So what is the structure of methanoic acid? It's like this one. So when OH is removed, what we are left with? HC double bond O here. And then the second one is propanol here. So here we will have 3 carbons, right? CH2, CH2, and CH3 like this one. So I have to find first CO, right? I already find it. Here it is also here. Then I have here and I have here. Clear? Now let's see further. First of all, we have to find our alcohol, that is propanol. So this side is 3 carbons. 1, 2, 3. Yes, that's right. And here, no carbon, only 1 carbon right here. So this is methanoic acid and this is propanol. So this option is right. Option A is correct. But let's see over here. Why this option is not right? Because if you see over here, this COOH, it means this is not actually your ester. At the end of the group, this is COOH and this is carboxylic acid functional group. The esters always have COO. They don't have COOH. Remember, you see CO and then we will have C. And this CO is always in the center somewhere. It's not at the corners. So that's why this option is the only right option here. That is A. This is actually a carboxylic acid that has 4 carbons and is actually butanoic acid. Okay. So this is the right answer. That is propyl methanoate. A. Question 66. What is the name of organic product of the reaction shown here? So if you see over here what we are using, this is our carboxylic acid and this is our alcohol, right? So alcohol names always come first. So if you look over here, how many carbons we have here? 2. So it's actually ethanol. How many carbons we have here? 2. So it is ethanoic acid. So the name of the alcohol always comes first. So ethanol will change into ethyl and ethanoic acid will change into ethanoate. So the name will be ethyl ethanoate. That is option A. Question 67. Which esters have the molecular formula C5H10O2? So you don't have to do anything. You just need to remember that esters are made from alcohols and carboxylic acids, right? So how you can get an ester with the 5 number? If carboxylic acid is 2 and alcohols are 3. If alcohols are 2 and carboxylic acids are 3. Or if alcohol has only 1 carbon, I'm talking about the carbon, okay? 1 carbon and it has 4 carbons. Or it has 4 carbons and it has 1 carbon. Okay, these are all the possibilities we can have. So let's see, is it right? Ethyl means 2 carbon. Propanoate means 3. So total is 5. Propyl ethanoate, again 3, 2, 5. Butyl, 4. Methanoate means METH, 1, 5. Methyl, 1. Butanoate, again 4. So 5. All will give you 5, right? So all these options are right. That's why option A is correct. The structure of an ester is shown over here. Which combination of carboxylic acid and alcohol produce this ester? So now they have given you a display formula here. So this COO is actually a part of the carboxylic acid. So it means this is your carboxylic acid. 1, 2, 3. So 3 carbon. That is propanoic acid. Okay, so that is the right option here. We don't have any other one here, right? No propanoic acid, so D is correct. But let's see for alcohol. This is your alcohol because it has O over here. H has already been removed, right, during the condensation reaction to make water. So how many we have water alcohols carbon? 1, 2, 3, 4. So it is actually butanol. So propanoic acid and butanol. Option D is correct. Question 69. The structure of ester W is shown. Okay. Which row gives the names of the ester W and the carboxylic acid and alcohol from which it is made up of? So if you look over here, this is our functional group COO, right? So now I will break this functional group. So the CO will be a part of carboxylic acid. So what is my carboxylic acid here now with 2 carbon? It is actually ethanoic acid. Where I can find the word ethanoic acid? Here. Okay, now let's see for here. This is my alcohol. How many carbons? Only 1. So it means it's methanol. First, 1 carbon is METH. So it's methanol. Both are right. Now let's see about the name. The name of alcohol always comes first. So it will be methyl ethanoate. Is it right? No. Methyl ethanoate. Yes. So option C is the right option here. Okay, question 70. The structure of an ester is shown here. Which alcohols and carboxylic acid produce this ester? Again, look at the functional group CO. Now, this CO is part of the carboxylic acid. How many carbons we have here? 3. So, it is actually propanoic acid. Where I can find the word propanoic acid? Here, yes. How many carbons are here? 2. So, it's actually alcohol, right? This O is a part of alcohol. So, alcohol with 2 carbons is actually ethanol. So, option B is the correct answer here. That is ethanol and propanoic acid. Question 71. The structure of an ester is shown. Which row identifies the name of the esters and the 2 compounds from which it is made? So, again, we will look at the ester group, right? I will break the bond. Now, this CO will be a part of the carboxylic acid. How many carbons I have? 3. So, it's a propanoic acid, right? 3 carbon, propanoic acid. Yes. How about this one? 2 carbons. So, it's ethanol, right? So, ethanol. Yes, right? So, the name is actually, the alcohol name will be the first one, right? So, ethyl propanoate. A is the right option here. Question 72. When the alcohol CH3, CH2, CH2OH, what is this? 3 carbons, so it's propanol, react with the carboxylic acid. How many carbons? 1, 2, 3, 4. Butanoic acid, right? An ester is formed. What is the name and the structure of this ester? So first of all, the name, again, if you look over here, this is 3 alcohol, right? It is propanol. So the name will be propyl. Okay. So the name will be propyl. And how many carbons we have here? This is butanoic acid. So the name will change to butanoate. Propyl butanoate. That is the right answer. Now, structure formula. The structure of the carboxylic acid will come first, right? So the CH3, CH2, CH2, and then CO. This OH will be removed during the reaction to make the water molecule. So where I can find here CH3, CH2, but no, right? I have to find 4 carbons. 1, 2, 3, and this. This is 4. Then, how many hydrogens? Oh, sorry, how many carbons from alcohol? 3. 1, 2, 3. Yes. So, option D is the right option here. Question 73. The structure of organic compound X is shown. What is X? Again, we will look at the structure, right? So, I break this bond and this carbon is now a part of the carboxylic acid. How many carbons I have? 2. Okay, so it is actually ethanoic acid. Okay, let's see from O to here, this is actually methanol, right? So now when we have to name the compound X, the name of alcohols come first. That is methyl ethanoate. So where I can find this word methyl ethanoate? Option C. So option C is the right option here. Question 74. The structure of an ester is shown. What is the name of the ester? Okay, again, we will look for the functional group. CO, this is my functional group here. So these two are a part of carboxylic acid. So the name, the carboxylic acid name comes at the end. 2 means ethanoate, right? So ethanoate is here. How many carbons I have here? 3. So it is alcohol, that is propanol. So propanol will change into propyl. So propyl ethanoate, option C is the right option here. Question 75. What is the structure of the ester formed from ethanoic acid and propanol? Okay. So ethanoic acid, we should know that ethanoic acid has 2 carbons, right? And how about the propanol? It has 3 carbons, right? Now the ethanoic acid, because when you are writing the structure structure of the carboxylic acid comes first. So we have to first find our ester group, C double bond. Oh, there is no C double bond O, right? So this is wrong. Here again, there is no. Okay, this may be right. Now I have to find the ethanoic acid. Okay, in the start, the ethanoic acid should have 2 carbons, right? But here we have 3, so it's wrong. Here, yes, I have 2 carbons. And how about propanol? 3 carbons? Yes, that's right. I have 3 carbons. So option D is the right option here. Question 76. Which display formula represent the ester formed by the reaction of propane 1-OL with ethanoic acid? Again, the same question. Okay. So propane 1-OL, 3 carbons. Ethanoic acid has 2 carbons. First, I will find the CO, right? CO. Okay, here again I have, here again. Now, ethanoic acid has 2 carbons. So in the starting structure, I will have 2 carbons. Yes, I have 2 carbons here. Here I have 3, so this is wrong. Here again, 3 wrong. Here I have 2. Yes, so this one can also be right. Now let's see for propanol. I should have 3 carbons in the propanol structure, right? So here, yes, I have 3. Here I have 2. So that is wrong. So option A is the correct option here. The structure of 4 molecules are shown. Which molecules react together to form ester propyl methanoate? So to make propyl methanoate, it means we have to react the methanoic acid, right? Because the last name is from the carboxylic acid and the first name is from alcohol. So we have to use a propanol. So where I can find the propanol? This is a carboxylic acid. So let me check. Is it methanoic acid? Yes, it has only 1 carbon. So it is methanoic acid. So first I'm going to use number 1. So it means A or B option can be right. No need to look over here. So 2 or 3, let's see. This is alcohol. That is only 1 carbon. But I have to use the propanol. And propanol should have 3 carbons. Right? So this one has 3 carbon, 1, 2, 3. So it means 1 and 3. Option B is the right answer. When they will react, they will make propyl methanoate. Question 78. Which structure represent the ester made from ethanoic acid and propanol? Again, ethanoic acid has 2 carbons, right? Propanol has 3 carbons. So when you are writing the structure, the ethanoic structure will be first, right? First, I have to highlight my CO. I gave, right? This is right. Okay. Now we will look at the ethanoic acid and propanol. Okay, let's break this bond. Oh, here the carbon double bond, if you look carefully, is on this side. So it means this is actually our now carboxylic acid. So the carboxylic acid is actually ethanoic acid, right? It should have 2 carbons. Yes, we have 2 carbons here, right? How many carbons should we have here in the propanol? 3. Yes, right. So that's why option A is correct. We can see all other options, but see here. How many carbons we have? 3. But ethanoic should have 2. Here, 3. Yes, that's right, but this is wrong. How about here? Again, we have 3 carbons here, right? But in ethanoic acid, we should have 2 carbons. Here, we have 2 carbons, but we should have 3. Again, here, if I break, this is 2 carbon. Yes, ethanoic acid. But here again, 2. That is wrong. So that's why option A is correct. So many students will do the mistake over here. They will think that this side is actually ethanoic acid. No. Or this side is actually ethanoic acid and this is actually the propanol. Because always when we are drawing the structure, we draw the structure of the carboxylic acid first. But here they wanted to confuse you. Whenever you have to look the structure, you have to look for the carbonyl bond. And when you break the bond, wherever the C double bond O will be, that side will always be carboxylic acid. Clear? So that's why option A is correct. Question 79. The structure of two compounds used to make an ester are shown. What is the name of the ester? So this is your carboxylic acid and this is your alcohol. Alcohol name comes first. So we have to see alcohol first. 2 carbons, so it's methanol. So methanol will be changed into, ethanol, right? It's ethanol. Ethanol will be changed into ethyl. So can I say a word ethyl over here? Yes, in the option A and in option C. Now let's see over here. This is 3 carbons. So it's a propanoic acid. So where I can find the propanoate? Yes, here in option A. So option A is the correct option here. Question 80. The structure of an ester is shown over here. Which substance react to form this ester? So again, first I will find the carbonyl group. Then I have to break it. And then if I break it, the carbon double bond O will go on the carboxylic acid side. So this is my 3 carbon carboxylic acid. So 3 is prop, right? So it's propanoic acid. Can I find the word propanoic acid? Yes, here. How about this one? This is my alcohol. So how many carbons? 2. So 2 ETH always, right? So it's ethanol. Here I can find the word ethanol. Yes, here. So option B is correct. Question 81. The structure of an alkene and the structure of ester are shown here. P and Q. What are the names of P and Q? So look at the first one, P. It's 1, 2, 3, 4. 4 means but, right? And if you look at the functional group, it's carbon-carbon double bond. So it's butene. Okay. Now, all of them are butene, but some of them are 1-ene, some are 2-ene. So what does 1-ene means? When the carbon-carbon double bond is between first and second carbon. So we will count it as first, right? So here, if you count the numbering 1, 2, 3, 4. You can count from any side again, it will be the same 1, 2, 3, 4. Every time the double bond is between 2 and 3, you have to choose the shortest number, right? That is 2. So it means it is butene. That's why C or D can be right. Now let's see for the Q. What is this? We have to force, this is ester, right? C double bond O. Now I will break this bond from here. CO will go into carboxylic acid part and this will go into alcohol part. Alcohol name always first. So how many carbons? 2 carbons. So it's ethanol, right? So ethanol name will change into ethyl when you are naming an ester. So ethyl, yes. But this is propane. That's wrong. So it means ethyl propanoate is the only right option here because we had 3 carbons here. So propanoic acid will change into propanoate. So option C is correct. Question 82. The structure of an ester is shown. Which row is correct? First, I have to look over here, right? I have to find what it is made up of. So again, I break this bond. So CO will go over here. This is my carboxylic acid. How many carbons? 3. So it's propanoic acid. How many carbons here? 1. So it's a methanol, right? So methanol and propanoic acid. Can I find this word here? Yes. So these two can be right. How about the name? The name of an alcohol always comes first. So methyl propanoate. Methyl propanoate. So option B is the right option here. Question 83. Which structures are structure isomers of each other? So now if you look over here carefully, they all are alkanes, right? In alkanes, we don't have any functional group. So whenever you are making the structure isomers, you can just remove the position of this CH3 and you can attach it anywhere in the group, but not at the corners. Remember, okay? So let's see over here. How many carbons I have here? 1, 2, 3, 4. So it is a butane. The name. Remember, in alkanes, the structure isomers will have different names. This is butane. How about this one? 1, 2, 3, 4. I told you already that the main chain is not always a straight chain. It can be in any direction. It can be like this, like this, like this, but you cannot go twice on the same line. Okay, so I just went once. You see one like here, right? So it has 4. So it's also butane. So both are same, not the structure isomers. Let's see here. Okay, let me go here. 1, 2, 3. I go here. 1, 2, 3. But now I cannot go here, right? If I want to go here, I have to come back. So I cannot repeat this place again. So it means this is 3 carbon in the main chain. So this is propane, right? And this is the side chain now. So this side chain is called 1 carbon, right? 1 carbon is always methane, but if it is methane is CH4 and this is CH3, so it will be called as methyl. When there is 1 hydrogen less in an alkane group, it becomes alkyl group. Okay, so this was methane, it becomes methyl. So the name of this compound is methyl propane. And which methyl propane? This methyl group is on which carbon? Carbon 1, 2, 3. It is on carbon number 2, right? So I will call it 2-methyl propane. I hope this point is clear to you. So it's mean butane and 2-methyl propane are the structure isomers of each other, 1 and 3. Or you can say 2 and 3, right? How about this one? Is this the structure? No, again, because if you go from here, this is the straight line. Or you can say the main chain, right? 1, 2, 3, 4. Again, it's same, right? So all these 3 are same. They all are butane. Only this one is the structure isomer of all these 3. So total we have 2 structure isomers here. Butane and methyl propane, right? So we have to choose 1, 2, 3, and 4. No, they all are not the structure isomers. Okay. Before finding the structure isomers, you also have to look that the number of the carbon and hydrogens are same or not. If you count here, the number of carbon will be of course 4 and the number of hydrogen will be 10. First, you have to count this one, okay? Don't forget. Okay, 1, 2, and 4 are the structure isomers. 1, 2, and 4. No, again wrong. This all are butane. 1 and 3 only. 1 and 3. Yes, that's right. 2 and 4. No, they both are butane. So they are not structure isomers. So C is the right option here. Question 84. The diagram shows the structure formula of 4 compounds. Which 2 compounds are structure isomers? Now, let's see again. 1, 2, 3, 4, 5. And this is alkanes, right? This is 1, 2, 3, 4. And this is 5, right? I know. So these are alkanes. How about this one? This is alkene. It has a double bond here. This is alkane. Again, so it means this is not the one, but these 3 can be the structure isomers of each other. Now we have to count the number of carbons. They should have same, right? This has 5, this has 5. Yes, how many it has? 1, 2, 3, 4, 5, 6. So it means this is not a structure isomer. Only these 2 can be the structure isomers of each other. But let's see once again. For structure isomer, the name should be different, right? 1, 2, 3, 4, 5. So what is the name of this one? This is pentane. How about this one? Okay, 1, 2, 3, 4. The main chain has only 4 carbons. So it is actually butane. And this is a side chain. This is methyl group. So this is called methyl butane, right? And this methyl is on the carbon number 2. Because if I count from here, it is 2. So 2 methyl. Okay, some student will say, sure, we can count from here also 1, 2, 3. So it can be 3 methyl butane. No, that's wrong. You always have to count from where you can get the smallest possible number for the side chain for alkanes, only in alkanes, okay? But in other homologous series, you have to count from where the functional group get the smaller possible number, okay? But in alkanes, we don't have a functional group, so we will consider side chain as our functional group, right? For example, so 2-methyl butane and this first one, they are the structure isomers of each other, 1 and 3. That is option A. Question 85. The structure of 4 organic molecules are shown. Which molecules are structure isomer of structure 1? Okay, so this is my structure 1. Let me check how many carbons I have in the main chain. So you will say, oh, we have 3. 1, 2, 3. No, you have to find the longest possible change in a way that you can get only highest number of the carbons, but it cannot be a straight chain, right? I can give you an example here. This chain has only 3 carbons, right? But if I go from here to here, this chain has 1, 2, 3, 4. So it means this is my main chain. This is the main chain and this is a side molecule, okay? So the main chain name we will give it, right? What is the main chain? That is has 4 carbons. So the name will be butane. Clear? Now the side chain will also get the name. This is only 1 carbon. So the name is methyl butane. Right? Which methyl? Is it on second carbon or 1, 2, 3, third carbon? Because this is third or second, right? If you count from any side. I will give the smallest possible number. That is the rule. So this is 2-methyl butane, right? Okay, now let's see over here. Is this the structure isomer? Yes or no? It has also same number of carbons, 1, 2, 3, 4, 5. Here we also have 5, right? Total 5. Okay, and now I will see the main chain. 1, 2, 3. This is not the main chain. Okay, 1, 2, 3, 4. Yes, this is my main chain and this is the side chain. So how many carbons I have in the main chain? 4. It's butane. Yes. And I have a methyl butane. Yes, methyl group. And it's on which carbon? Carbon number 2. So are they both same? Yes. So they both are not the structure isomers of each other. So 2, wherever I will find the word 2, I have to put a cross. So I'm just left with these 2 options. Let's see for the third one. Okay, let's start counting from here. How many carbons I have in the main chain? 1, 2, 3, 4, 5. So this is my main chain. 1, 2, 3, 4, 5. Because I go in a same direction and I did not repeat it on the same line, right? So it is actually pentane with 5 carbons. The main chain is just like this one. Okay, don't consider a straight chain as the main chain only. Remember, in organic chemistry, the longest chain is actually the main chain. And the longest chain can be in any shape. Clear? But you cannot repeat on the same line or you cannot cross the same carbon again. Okay? You have to just go by one carbon at once. Okay, this is pentane. So 1 and, okay, so the 3 is the structure isomer of the 1. That is possible, right? So 3 is right. Now let's see, we have to confirm it's 4 or it's only the D. So let's see over here. Main chain, 1, 2, 3, right? I can also consider this one as a main chain, 1, 2, 3. So this is also same. Then 1, 2, 3. Every time when I see the longest chain is always 3 carbon. So it's not possible to get more than that. So it means I can consider this one as my main chain. It's my choice because from all the direction, 3 is the main number. So it means propane. 3 carbon means propane is the main chain. Now I take this as my main chain. So this is the side chain, right? So how many carbons I have here? Now you will say, oh, we have 2, so it's ethyl. No, this carbon is bonded to 1 carbon separately and 1 carbon here separately, right? So it is attached with methyl group. Again, here also methyl group. So instead of writing methyl, I will say dimethyl. It is attached with 2 methyl groups, one here, one at the bottom, one at the top. Okay, dimethyl propane. So the name of this compound is dimethyl propane. Okay, now I also have to tell that where this dimethyl is present. This methyl group is present on carbon 1, carbon 2 or wherever. If you see 1, 2, it is present on carbon number 2, right? So I will say it 2, 2 dimethyl propane. Okay, remember the side chains and the main chain have no space in them. Fine? Okay, no space. Second, between the words and the numbers, this is a word, right? It's alphabet. And between the number, there is always a slash sign or a hash sign. But between numbers, it's always comma. These are the rules. If you write like this, 2, 2, comma, it will be wrong. You will get 0, okay? Another thing you have to remember that how many times the methyl group came over here, dimethyl, right? You say, oh, I can write 2-dimethyl. No, because sometimes this dimethyl, this methyl group will be on the carbon number 3 like this, 2, 3. So you have to mention how many times you are mentioning the carbon, the side chains. You have to mention on which carbon are they present. So both of them are present on the second carbon. So that's why you have to write 2 times the word 2, 2. 2, 2 means the carbon number 2 has methyl, and then again carbon number 2 has again methyl. So that's why 2, 2-dimethyl propane. So 2, 2-dimethyl propane and pentane, and this is 2-methyl butane, all have 3 different names. It means 3 and 4 both are the structure isomer of the structure 1. So option C is the correct answer here. Question 86. Which molecules are structure isomer? Okay, so to find the structure isomer, first we have to see which one of them are belonging to same homologous series. Here it's alkane. This is also alkane, right? How many carbons? 1, 2, 3, 4, and here I can find the 5th one. 5 carbons here. How many here I have? 1, 2, 3, 4, 5. Yes, total 5 carbons. They can be homologous series. We will see now in detail. Let's see over here. How many carbons I have here? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So it means they are not. It's not possible for them. They are from the same functional group. So only 1 and 3 can be, there's a chance, right? So I'm not going to count because their carbon numbers are not same. So they cannot be structure isomers. So only option is 1 and 3. But for your better understanding, I can give you the name. Let's see the name of this one. The main chain has only 4 carbons and the side has this methyl group, right? So main chain 4 carbons, so it's actually butane. Side is methyl. Yes, so it's methyl butane. And on which carbon it is? On carbon number 2. So I will say 2. And you see a slash sign because it is a number and it is a word. So 2-methyl butane. Let's see over here. How many carbons I have in the main chain? Only 3, right? So this is 1, 2, 3, right? So I will call it propane, right? Okay, now 1, 2. So 2 on the carbon number 2, I have methyl group again. So it's a dimethyl propane. And on which carbon it is? So on carbon number 2 both times. So 2,2-dimethyl propane. So 2-methyl butane and 2,2-dimethyl propane are the isomers of each other. That is option B. Question 87. Which compounds contain the same number of carbon, hydrogen, and oxygen atoms? Okay, let's see over here. It's simple. Okay, ethyl methanoate, 2 carbons. Methanoate means 1 carbon, METH. Total 3. Methyl 1. Ethanoate means 2. Total 3. Methyl 1. Methanoate 1. Total 2. Ethyl ethanoate 2 plus 2 is equal to 4. So who has same number? Simple. Ethyl methanoate and methyl methanoate. W and X. That is A. Question 88. The structure formula of 2 hydrocarbons are shown. Okay, which statement about the hydrocarbon is correct? They are both alkenes. No, there is no double bond here, right? They decolorize aqueous bromine. Again, wrong. Only alkenes can do so. It's not right. They are structure isomer. Yes, that's right. If you see over them over here, they have same number of carbon. They have same number of hydrogen, but the structure is different. The first carbon has 3 hydrogen. Yes, same. But the second carbon has 2 here. Here, the second carbon has only 1 hydrogen, right? So structure formula is different. But the number of carbon and hydrogen, if you count, they are same, right? So they are structure isomer. Option C is right. They undergo addition reaction. Wrong, because they are not alkenes. Only alkenes can do addition reaction because they have carbon-carbon double bond. Question 89. Which substance are structure isomer? Okay, butene and propene. Propene has only 3 carbon. Butene 4 carbon. Not possible. Ethyl ethanoate and butanoic acid. Okay, remember esters and carboxylic acids are the structure isomers of each other if they have same number of carbon. You just have to look for the number of carbon. You don't have to make the structure. Ethyl, look at the word ethyl. It means It has 2 carbon. Ethanoate also 2. So total how many? 4 carbons, right? Butanoic acid, the but words means 4. So both are 4, it means they will be. Okay, remember, esters and the carboxylic acids are structure isomers of each other if they have same number of carbons. That's true. So I just give you the trick. You have to just find the number of the carbons here. We have 4, also 4. So it means B is the right option here. Okay, question 90. Butene has 3 structure isomers which are alkenes. Which statement about these isomers are correct? They have same molecular formula. Yes, the structure isomers are the compounds. They have same molecular formula. What does it mean? They have same number of carbon, hydrogen or oxygen if they have like, okay. But their structure formula will be different. Okay, number 2, they have different number of bonds in the molecule. Wrong. When their molecular formula is same, the number of bonds will also be same. Only the structure will be different. Okay. Then third, they have a carbon-carbon double bond in the structure. Yes, because it is alkenes, so they will have a carbon-carbon double bond in the structure, right? So 1 and 3, that is option B. Option B is correct. Question 91. Butane and methyl propane are isomers which with molecular formula C4H10. Which statements are correct? They have similar chemical properties. Yes, because they both belong to same homologous series, right? So the structure isomers, it's not because they are structure isomers, but because they are belong to same homologous series, that's why their chemical properties are similar. Okay, they have same journal formula. Yes, true, because they both belong to, you see, ANE, alkane group, right? They had the same structure formula. No, that's not right because they are isomers of each other. The structure formula will be different. So 1 and 2, that is option B is the correct option here. Question 92. The hydrocarbon C4H8 has 2 structure isomer, but1ene and but2ene. So what does 1ene and 2ene mean? Let me tell you just then we can go ahead. Okay. So from the word butene, you can know that it has 4 carbons, right? And it is ene. So according to the general formula, the number of hydrogen will be double, C4H8. It will also have the same because the molecular formula is same. But the structure formula is different. So CH3, there are 2 possible ways I can write CH2 and then I can write CH double bond CH2. At least there will be 1 double bond, right? Because it's alkene. So what is the name of this compound? Because if you see the carbon number 1 has a double bond. If you recall, I told you that the numbering of all the homologous series except alkane, because alkanes don't have any functional group, the numbering of all the compounds in other homologous series will start where you can get a smaller number for the functional group. So I'm not going to count from here as 1, 2, 3. No, I will count from here because from here, the 1, it will get a smaller possible number for the functional group, right? So the functional group is on carbon number 1. So this is actually your butene, right? So you can see why this 1 is here in the middle, not in the start. It's not like this. The problem is not with but. So why but should write 1 with it? The problem is with carbon-carbon double bond with the functional group, right? And the name of the organic compound, because of the functional group, is at the end, right? The starting always tell you the number of carbons, and the number of carbons are same. It's 4, right? So why butene should take the 1 or 2 word? It's the problem is with E and E because E and E tells you that there is a double bond between carbon and carbon. So you have to tell that which ene is this one. Is it on carbon 1? Is it on carbon 2? Or it's on 3? So the name will be butene, and in between again remember that between number and the word it's always a line, okay, or a hash. It's not a comma, right? So I will write here but1ene because the carbon 1 and 2 between is 1 and 2, so 1 will be the smaller possible number 1. Okay, it's but1ene. How about but2ene? It means that the carbon-carbon double bond is over here between this one, right? Like this. Okay, now I have to put H over here. So if you see, this is complete, right? This has 3 hydrogen here and 1 here. If you look at this carbon, it already made 2 double bonds here and one here, right? So it already made 3 bonds. So it has to make only 1 bond. So that is H with H. So it has only 1 H. Let's see over here. Okay, this has only 1, 2, and here also with this carbon, right? Third. So H will be here. Clear? So this is actually butene. I can count from here 1, 2. It will get as small as possible. Or I also can count from here. Again, it will get the smallest possible number. So this is butene. They both are the structure isomers of each other. You see, the first one has CH3, same. But this one, the second carbon has 2 hydrogen. But here the second has 1 hydrogen. Here the third has CH, same like this one. Here the fourth one has CH2, or like the first one, right? But here the first one, or you can say the fourth one, has just CH3. So the structures are not same, but their molecular formula is same, right? So this is how you can draw the structural isomers of other homologous series. You have to just shift the position of the functional group. Only alkanes is different. In alkanes, you have to move the CH3 group at somewhere to make the another compound, right? And to make you can say like to make another chain. You cannot make a straight chain. You have to make some branch chains to make a isomer for the alkanes. But for alkenes, it's simple. You can just move the position of the double bonds. And for alcohols, you can move the position of OH. From first carbon, you can move it to some maybe on the second carbon or maybe on the third carbon, and you can get the structure isomer easily, right? So now let's see which statement is correct over here. Butene has the structure formula CH3, CH3 and the same general formula as a butane. Yes, this is right, but this is wrong. General formula is same like butene. Why A and E? It's E, right? So it's wrong. Butene has the structure formula again and the same empirical formula as ethene. Yes, this can be right. We can see here. Okay, this is right because the carbon number 2 has the double bond. So that's right. Okay, empirical formula is ethene. How many carbons we have here? C4 and how many hydrogen? 8, right? Ethene again belong to the same homologous series. C2H4. The carbon numbers are double, right? So CH2 is the empirical formula for ethene. How about this one? Again, CH2 is the empirical formula. So it means B is the right option here. Okay, let's look over here. That butene has the structure formula like this one and the same molecule empirical formula as like this. So it has the same empirical formula like ethene, that is right. But how about the structure formula? No, that's wrong. I already made the structure formula for here. CH2 at the end, it should have CH2 here and CH over here. So it has been wrong. This structure formula is right, but this information is wrong, right? So B is the only right option here. Okay, let's see question 93. Which structure represent a pair of structure isomer? Let's see the first one. We have to count the number of the carbons first and all of them. So the first one has 1, 2, 3, 4, 5, 6, 6 carbons. How many here? 1, 2, 3, 4, 5, 6, 7. Because it's 2 here, right? 7. Then 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6, 7. So we have 7 here. It means B or C can be right. Now let's see how we can draw the structure and we will see. So this is just a simple straight chain, right? Like 1, 2, 3, 4, 5, 6. Yes. Let's see over here. This is carbon. Then we have CH. And then we have again CH2, CH2, and CH3. And this is in the bracket always when we are writing the alkanes and the side chains are written in the brackets. So it means this is not a straight chain. It is 1, 2, 3, 4, 5. It's a pentane, methyl pentane, and this is a hexane, right? So these two are the structure isomers of each other. That's true. B is the right answer. But let's see now for 2 and 4, why they are not. Okay, we will draw the structure of this one now. I have 1, 2nd, 3rd, 4th, 5th, and then the 5th one is attached to 2 CH3. So one I can write here the CH3, the other I have to write somewhere else, right? Here or here on the top, anywhere I can write. So let's name this compound. What is the name of this compound? So in the main chain, if you look carefully, we have 6 carbons, right? 1, 2, 3, 4, 5, 6. So it's hexane. And then this is methyl hexane, right? And this methyl group is on the second carbon. I will not count from here because here it will get a large number. We have to give the smallest possible number for the side chain, and that is 2 methyl hexane. Now let's see over here what will be the name of this compound. Okay, first it's CH3, right? Then the second is CH again, then we have CH3. So then this CH3 will come over here on the top, and then we have CH2, this one I'm talking about because it's in the bracket, so it's like a side chain, right? CH2, 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 and then CH3. So you see, you can say, oh, it also have a side chain, but if you see clearly, I will give the smallest possible number from where it gets, right? This side chain. So it's a 1, 2, 3, 4, 5, 6, again hexane, methyl hexane, and 2 methyl hexane. Everything is same, not structure isomers. They are the same compound. So it means only option B is correct. Question 94. Which pair of compounds are structure isomers of each other? Let's see one by one. Okay, A, 3 carbon, and there we have 4 carbon. Not possible. Here, 1, 2, 3 carbons. Yes, 3 carbons. But let's see for the number of the position of the double bond. This is alkene. So the carbon number 1 has a double bond here. Not carbon number 3. Again, the smaller possible number it can get. So I will say 1, 2, 3. Again, the carbon number 1 has a double bond, right? So again, they are safe, not the structure isomers. Let's see over here. Okay, 1, 2, 3 carbon. 1, 2, 3 carbon. Yes. So the first carbon have the 1, 2, 3 has the OH group, right? I have to give the smallest possible number to the functional group. So this is actually propanol, right? Because it has 3 carbon, but I will call it propane 1OL. Okay, here it will come 1OL. Why? Because this OL is on the first carbon, right? So how about this one? Is it also propane 1OL? Yes, it's also propane 1OL because if you see over here, this CH2, then this is CH2, this is CH3. And this one is on the side, maybe here somewhere. But again, it is on the first carbon, right? So it's again propane 1OL. So they are also not structure isomer. They are same compound. Let's see over here. What is this? In the center, I have CO. That is an ester, right? So if the esters and the carboxylic acid, I already told you, if they have same number of carbons, they will be, of course, the structure isomers of each other. So let me count the number of carbons. 1, 2, 3, 4. 1, 2, 3, 4. Yes. So you can also count the number of hydrogens and oxygen. It will also be same. So option D is correct. Question 95. The structure of 2 molecules X and Y are shown. Okay. Which will describe X and Y? Okay. Are they structure isomers of each other? First, we have to find the number of carbons. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. No. There we have 6 and here we have 7 carbons. So they are not structure isomer. A or B can be right. Belong to same homologous series. Yes, because they both have a carbon-carbon double bond here. So yes, option B is correct. Question 96. The structure of 2 compounds are shown. Which statement about these compounds are correct? So they both are, if you look over here, this is COH. Not COOH, right? Remember, this OH is attached to C directly, but here, this carbon is attached with H, not with OH directly, right? You can see over here, it is attached with the OH. Here, it is attached separately with OH and O. So they have the same molecular formula. Let's see how many carbons we have here. 3, 2 oxygen and 6 hydrogen. Okay, 1, 2, 3, 4, 5, 6 hydrogen. 2 oxygen, yes, and 3 carbon, yes. They have same molecular formula. They have similar chemical properties. No. For similar chemical properties, they should have a same functional group. There we have a carboxylic acid functional group, right? You can see over here. But this is a carbonyl group, CO, you can say. Okay, but this is not a carboxylic acid. Be very careful. C is not attached directly with OH group. It is attached with O separately, with H separately, right? So they both are different functional groups. They are structure isomers. Yes, we can say they are structure isomers because after 2 carbons, we have oxygen. Here, after 2 carbons, we again have a carbonyl group, right? CO and then OH, carboxylic acid. Then after O, we have a carbonyl and then H. So they are structure isomers of each other. So option 1, 3, that is D option is right. Question 97, which statement about structure isomer is correct? They have same structure but different reactivity. Wrong. The structure will be different. That's why we call them structure isomers, okay? They have same journal formula. No, it's not possible always because carboxylic acids and the esters, they don't have a same journal formula, right? So let's see for the C, they had the same structure but different relative molecular masses. Again, wrong, not same structure. They have different structures, but the same numbers of each type of atom. Yes, the structures are different, but the number of atoms and the type is same. So option D is correct. Question 98. Which statement about homologous series and isomerism is correct? Butane and butene are structure isomers. Both belongs to different homologous series, not the same molecular formula or journal formula. So A is not right. Compounds in the same homologous series have the same journal formula. Yes, that's right. So option B is correct.